All right, so we are going to review, or not review, I guess it's introduce, how to do an ANOVA in PSPP. So this is the same data set that you can download. I've provided it on the class page if you want to follow along. I'm in variable view. And what I have entered is I created a student number to go along with it just so I would have something to keep record. A student number, the class, and the test score. And over here with the class, I've gone ahead and put our value labels in that group 1 is the ones listening to classical music, group 2 is the ones listening to fan favorites, group 3 is the one listening to ambient music. And then I have their test scores entered. And this is exactly the same as the chart that I have back here. So let's come over here to data view. You can see this is all filled out. So to do an ANOVA in PSPP, we're going to come to analyze, and because it makes it so helpful, you will notice the word ANOVA is not anywhere on this menu. The word F-test is not anywhere on this menu. They're calling it a univariate analysis. So we are going, or no, they do not. We are going to get to univariate analysis when we get to factorial ANOVAs. I skipped a step. You will come over here to compare means and find a one-way ANOVA. Next, we're going to talk about factorial ANOVAs, and that's when you're going to do univariate analysis. But, so I misspoke there, my mistake. Been a long week. So compare means one-way ANOVA. You're going to click one-way ANOVA. All right. Remember, in PSPP and in SPSS, ANOVAs, the independent variable is referred to as a factor. What is affecting what? Type of music is affecting test score. Type of music is independent variable. Test score is dependent variable. So for our factor, we're going to tell it the class. For our dependent variable, we're going to tell it the test score. And just for the heck of it, let's tell it we want descriptives. Now, if you click this without clicking any post hoc analysis, what you're going to see if you go ahead and click OK is on your ANOVA table, it'll tell you that there is a significant difference. So we're going to come down here. Again, we ask for our descriptive. So this is stuff we've already discussed, our means, things like that. But if we come down here to our actual ANOVA, we'll see our F statistic of F.18, and we'll see that there's a significant difference of 0.002. But we don't know what that means. So what we know from this window is there is a significant difference happening somewhere here, right? And by common sense, we can look at this and say, well, group 1's mean is all the way up here at 7, whereas the grand mean is at 5.1, and these are all down in the 4s. So the significant difference is probably something happening over here with group 1. So we could kind of common sense that out based on the numbers. But the way that it's shown on this table, all it tells us is somewhere there's something significant. So then we need a test where we can determine, okay, what is it that is significant that's happening here? And that's why we always use a post hoc test if we have a significant difference within ANOVA. So let's close this and come back over here, analyze, compare means, one-way ANOVA. And now we're going to click on this post hoc. Now, explaining the difference between all of these one-way ANOVA post hocs is far beyond the scope of this class. Always use Tukey HSD. Sometimes you'll see Bonferroni referenced. Sometimes you'll see Fisher's LSD, which is least squared differences, I believe is what that stands for. But we always use Tukey. Again, explaining the differences is beyond the scope of this class. I can give you some resources if you're curious and would like to read on it, but use Tukey. So click continue. Now click OK. And what you're going to see in your output now is this follow-up of a multiple comparison test score. And this is going to point out where your significant differences are. So comparing classical to fan favorites, there's a significant difference. Comparing classical to ambient, there is a significant difference. And so you can go through this chart and identify which groups show significant relationships between them. significant differences between them. You'll see that fan favorites and ambient really don't have any significant difference going on between them. So with those two, it didn't make a difference if students were listening to fan favorites or ambient noise, ambient music, which again, our means kind of tell us that, right? There's really not much of a difference between 4 and 4.3 if you're comparing it to a grand mean of 5.1. So again, we could have looked at that and probably guessed that that was what was going on, but we never want to guess. We want to look at the analyses. So what this table tells us is that classical music was significantly different than the other two types of music. And the other two types of music, fan favorite and ambient, were not statistically significantly different from each other. So that is how you run and interpret an ANOVA in PSPP. Now we're going to move on. That was a one-way ANOVA. Now we're going to move on to a factorial ANOVA and discuss what that means and how we interpret it.